All right, good evening, everyone. Thank you for being here tonight. We are Novigrad, and this is our Sigma Demo Day presentation.
So I'll introduce myself first. My name is Christopher Elash. I'm currently a PhD student in electrical engineering. Right here at USask, I study semiconductor reliability.
And my name is Lars Kiszczuk. I graduated in 2021 with a computer engineering degree. With Chris, actually, we were capstone partners together. And currently, I'm a senior software developer at Siemens EDA as my day job. So now I'll talk a little bit about our problem at a high level. So computers don't always do what they're told. If you work with computers, you may know this. So modern computer chips suffer from reliability issues just like any other part. So they break down often. And effects from radiation is actually one of the leading reliability issues today. So you may have seen the picture on the right where your computer stops functioning for some reason. It's kind of a mystery. So now I'll talk a little bit about radiation exposure. So even on Earth, there is radiation exposure. So on Earth, data centers expect to have some failures every year due to cosmic rays kind of causing bit flips. So that's kind of on the lower end of radiation exposure. Then going up in the atmosphere to planes, there's actually an example of Qantas Flight 72. They nearly crashed due to a radiation-induced failure in a flight computer. And then going even higher up into outer space, that's where you have the most radiation exposure. And satellites in orbit will commonly fail due to all the radiation that they are exposed to in orbit. So now I'll talk a little bit about our idea. So our original idea going into Sigma was just to build expensive chips that will endure the radiation exposure. So if you use some fancy techniques to build these computer chips, this is based on Chris's research here, then the chips can just survive and everybody's happy. Except building computer chips is very expensive and building specialized computer chips is even more expensive. So through the process of Sigma, specifically our market research, which we found to be most interesting, we talked with the companies on the right here, so you may recognize some of them. So MDA Space is known for making the Canadarm. Microchip is a semiconductor company. Rocket Lab, Cloudflare, and SpaceX with their Starlink fleet. What we found through this and talking with these companies is that what companies and customers really want is test data to inform risk mitigation decisions. They won't buy expensive chips if they don't have to. At the end of the day, they're a company, they're trying to make money, and if they don't have to buy something really expensive, they're not going to.
Okay, so that comes to what our solution is and kind of what we developed over the summer. So what we aim to be is Canada's first and then only contract electronic parts radiation service provider. There's actually a lot of space companies that send satellites into orbit without thinking about these radiation effects with that much detail. And then unfortunately later on they suffer reliability issues with their constellation in orbit, and it's just something they can't fix once it's already launched. So ideally, what they're looking for is they're looking for more test data and better failure analysis for their parts before they launch. So we would do things like instantaneous testing. So that's when the parts are irradiated actively, and then we're looking for failures, as well as longevity testing, so they can understand how long will this part actually operate when it's in space or a different high reliability environment. And then based on that data, we can better inform their risk mitigation decisions. And actually, we're in a really good spot right here in Saskatoon to do this. There's a lot of pre-existing infrastructure at the university that we can take advantage of. As an example on the left there is that we have Canada's only pulse laser testing facility specifically built to do radiation semiconductor analysis. So that's a really great thing to have right here in the city. And then thinking long term, we still do have the idea to eventually build these very expensive chips one day. And if you want to talk a little bit more about that, we actually have a demo for one that's undergoing a test at our table there, but we can talk about that later. Talking about what's next, I think it's no secret there's a lot of increased interest and as well as spending in the Canadian defense industry. So we're still exploring the viability of the business, and then we're also having some discussions right now with some Canadian defense partners to understand future projects and how we could potentially contribute to them. And we're also having some active discussions with some American entities down south on how we can kind of join forces and have some collaboration there. And then to wrap it up with some kind of overall thoughts and advice we have for people, me and Lars have always talked about doing a business or entrepreneurship together, and we've gotten to various stages in that process, but eventually kind of fizzles out for one reason or another. But Sigma gave us a really good structure for us to actually go through the whole process and gave us a lot of motivation to continue. It's really great when you have external deadlines to meet, so you're always moving forward and making progress. And our advice for anyone looking to start is just to do that, is just to start and go out and talk to people, find out what their problems are, and figure out where you can provide value for them. Sigma provide a really safe space for us to ask questions and try some things and fail. There's a lot of great connections you can get within the community here. And even the lessons learned, even if you don't pursue entrepreneurship afterwards, I think they're valuable to any job you might have in the future. So with that, I'd like to thank you for your attention, and we'll look forward to talking with you afterwards.